This is a video on differentiation. The emphasis will be on the chain rule for specific types of functions. Let's take a look at the first rule. The derivative of x to the n with respect to x is nx to the n minus 1. So this is the power rule. Now, for example, suppose I want the derivative of x to the negative 5 with respect to x. This is negative 5x raised to the negative 6 power. Because remember, n is equal to negative 5, and negative 5 minus 1 is negative 6. Okay? If we do another example, suppose we want the derivative of x to the 1/2 with respect to x. N doesn't have to be a whole number or integer. N can be a fraction too. And so what we get is 1/2 x, and then 1/2 minus 1 is negative 1/2. And so that will be the exponent on the x. And then I'm going to rewrite this as 1 over 2x to the 1/2. Now, let's take a look at this second rule here. Suppose I want the derivative of f of x raised to the nth power. And this is where we get to apply the chain rule for a specific type of function. Now, I'm going to take n, I'm going to multiply it by f of x raised to the n minus 1. And then I'm going to take this result and multiply by the derivative of f of x, which is f prime of x. So this is the chain rule for a specific looking function. Now, for example, if I want the derivative of x squared plus 1 raised to the 5th power with respect to x, in this example, n is equal to 5, and my function, f of x, is x squared plus 1. That's the inside function. And so if I apply the second rule, we get the following. We get 5 times, and then I'm going to say x squared plus 1 to the 4th power, and then I'm going to take that answer and multiply by f prime of x, but f prime of x is equal to 2x. And if I simplify this, 5 times 2x is 10x. And so I get 10x times x squared plus 1 to the 4th power. And so therefore, the derivative of x squared plus 1 raised to the 5th power is 10x times x squared plus 1 to the 4th. So that's the chain rule. Let's do a second example. Suppose I want the derivative of, and we'll do this one. How about x squared plus 5x minus 3 to the negative 5 power. So in this example, n is equal to negative 5, and my function is going to be this piece here, which is x squared plus 5x minus 3. So again, we're looking at the chain rule for a specific looking function. Now, let's rewrite this. So I want the derivative of x squared plus 5x minus 3 raised to the negative 5. So I'm going to write the negative 5. Now, my function is x squared plus 5x minus 3. And I'm going to raise that to the negative 6. And I'm going to take that answer and multiply by f prime of x. Now, let's take a look at f prime of x. The derivative of x squared is 2x, right? The derivative of 5x is 5. And so I'm going to say plus 5. The derivative of any constant is 0. And so I'm done. Now, if I simplify further, I get negative 5 times 2x plus 5 times x squared plus 5x minus 3 to the negative 6. So from here, I'm going to distribute the negative 5 inside. When I do that, I get the following. So the derivative of x squared plus 5x minus 3 to the negative 5 is equal to. Now notice, if I distribute, I get negative 10x minus 25. So I get negative 10x minus 25 times x squared plus 5x minus 3 raised to the negative 6 power. Now, let's take a look at a third rule. The derivative of e to the x with respect to x is equal to e to the x. So that one's really nice, okay? There's not much to that particular rule. Now, with that being said, I want to take a look at rule 4. If I look at the derivative of e to the f of x with respect to x, well, it's going to look similar to rule 3, but with a slight twist. And so I'm going to write e to the f of x, and I'm going to take that answer and multiply by f prime of x, like so. Now, let's take a look at a couple of examples here. So, if I take a look at the derivative of e to the x squared with respect to x, in this specific example, notice that f of x is equal to x squared. And so I get e to the x squared. And I'm going to take that answer and multiply by the derivative of x squared. But the derivative of x squared is 2x. And so I'm just going to write this as 2x e to the x squared. And I'll just make a note here that if you can understand the chain rule for these specific types of functions, I believe this is going to help you understand the substitution rule, or basically use substitution for integrals that much better. So this is why I'm going over these specific types of derivatives. Now, let's take a look at a second example here. Suppose I ask you for the derivative of e to the x plus 5 with respect to x. Now, in this example, f of x is equal to x plus 5. Now, one thing to take note of is that f prime of x is equal to 1. And so if you notice, we get e to the x plus 5 because that's my function, but then I'm going to multiply by 1 because that's the derivative of f of x. And so when I simplify, I get e to the x plus 5. That is not a coincidence, by the way. So generally speaking, so let me write this in this way. In general, the derivative of e to the x plus some constant c with respect to x is equal to e to the x plus c. So that's going to be true in general. And you can see when you take the derivative, you get 1, and the derivative of any constant is 0. So it works out really nice. Now, let's take a look at number 5. If I look at the derivative with respect to x of natural log of x, I get 1 over x. Okay. On number 6, the derivative of natural log of f of x with respect to x, it's going to look very similar to number 5. Okay. So what you end up getting is 1 over f of x multiplied by the derivative of this inside function here, which is f prime of x. And if you don't mind, I'm going to write this as f prime of x divided by f of x. Now, let's take a look at a few examples for this specific case. For example, suppose I want the derivative of natural log of x squared plus 1 with respect to x. Okay. Now, in this example, my function, my inside function here, is x squared plus 1. And so the derivative of x squared plus 1 is equal to 2x. And so I'm going to write 1 over the function, which is x squared plus 1. And I'm going to take that result and multiply by the derivative of x squared plus 1, which is 2x. And so this is 2x divided by x squared plus 1. Let's take a look at a second example here. So if I look at the derivative with respect to x of natural log of, doesn't matter, we can do e to the x plus x squared. Okay? So remember, we're trying to expand our repertoire of functions. Now, in this example, f of x is equal to e to the x plus x squared. That's my inside function. F prime of x is e to the x plus 2x. And so I'm going to get 1 over e to the x plus x squared. Okay? But I have to multiply by the derivative of that function. And the derivative would be e to the x plus 2x, like so. And so if I were to simplify, the derivative of natural log of e to the x plus x squared with respect to x is e to the x plus 2x divided by e to the x plus x squared. And so I want to give you really a brief glimpse of where I'm going to be headed with this. If we can understand the chain rule, right, being able to integrate a wider variety of functions will become easier. Do you know what I mean? What do I mean? So now we just established, right, that let's say the derivative of natural log of f of x with respect to x is equal to 1 over f of x times f prime of x. So this is the chain rule for a specific looking function. Okay? Now, so what I want to be able to do is give you the following. Now, suppose I give you x squared plus 1 in the denominator and I give you x in the numerator. And I want to integrate this with respect to x. Okay? So this is again where I'm headed. Now, f of x is equal to x squared plus 1. F prime of x is equal to 2x. Now, my function is x squared plus 1. But the derivative is 2x, and so the question is, what's missing? Well, we're missing a 2. So I need to put a 2 in there, right? But I can't just do that, okay? And so if I put a 2 in the numerator, I have to multiply that integral by a half. Because remember, 1/2 of 2 is 1, and when you multiply by 1, you've changed nothing about the problem, okay? And so if we work backwards, right, the integral of f prime of x over f of x dx will be natural log of f of x plus c. Well, so here, if I were to carry this out, I'm going to get 1/2 natural log of x squared plus 1, right? That's natural log of the function, plus some constant c. And the only reason why I have a constant is we're looking for a family of functions, right? The derivative of any constant is 0. So there could be a family of functions that satisfy this. And so I want you to have an ability to be able to work backwards with a wider variety of functions. That's ultimately where I want you to arrive at when you practice the chain rule. So I hope this video helps. I'm going to make another video where we'll look at some different functions applying the chain rule. So, all right, thank you.